Hello everyone, in this video I will use the Siemens S7-1200 PLC, this small controller, and to control two servo drives. That's two servo drives come from Siemens SINAMICS S210 servo drive. And this servo drive is a cost-effective and easy to use servo drive. And S7-1200 PLC, it has standard PLC and it also has safety built-in controller. So this is also the cost-effective CPU. And the communication between this CPU and the servo, I will use PerfectNet RT communication. And usually when we do the positioning control, the Siemens will recommend using S7-1500 PLC and the servo drive controllers S210 or S120 servo drives. I used multiple videos to show how can we set up the technology object TO and how can we set up the PerfectNet IRT communication to do that. Usually the communication telegram will be 105. And the 105 includes the DSC function. That full name is Dynamic Servo Control. However, for the Siemens S7-1200 PLC, it doesn't support PerfectNet IRT communication and synchronized RT. It only supports PerfectNet RT communication, real-time communication, like showing here. Also, S7-1200 PLC does not support Telegram 105. It only supports Telegram 123. So for the positioning control, we have to use Telegram 3. The Telegram 3 doesn't support the DSC function. Using the Telegram 3 without the DSC function, that means the PLC will place the role for the positioning controller. The gain will locate at the CPU at the PLC side. Because of the CPU runs the role as a positioning controller, so the reaction time will be much slower than the positioning closed loop located in the drive, in the server drive inside. So using this cost-effective solution, I would recommend do not run the motion control, run the servo control with a high dynamic application. You can run the high accurate positioning control, but do not run the high dynamic positioning control because the closed loop rely on the communication and rely on the workload of this CPU, this PLC. So according to this, while we are doing the one-button tuning for the servo drive, we better select the conservative to do the one-button tuning. Also, according to this, some setting from the PerfectNet communication RT and the MC servo, this OB91, this communication bus cyclic time, we need to set based on some rules. And also the P1416 from the drive, we need to tune the speed setpoint filter a little bit. So I will show this case. Again, comparing with 1500 PLC and the servo drive, this 1200 PLC and the servo drive could be a very cost-effective solution to provide the positioning control. Just do not do the high dynamic positioning control. All right, let's start. Let's go to the servo drive at first. I will use the web page of this SINAMICS S210 to configure the servo drive. All right, firstly, let me introduce this demo. In this test, I'm using S7-1200. This is the S7-1214, and its firmware is a firmware 4.6. And the network from this port, from this PLC, I'm connecting this blue Ethernet cable, go to this drive, the top port. And then the bottom port connect to the second drive, the top port. And then while I'm programming the PLC and the drive, I will connect to this port. So this whole network, they are PerfectNet network. But in this test, since the 1200 PLC does not support the IRT, PerfectNet IRT communication, it only supports RT. So it doesn't need the top logic configuration. We only need to connect to a network, that's enough. So we can provide one simple Ethernet switch. So all those drive and the PLC, they can connect to one simple Ethernet switch. And at the early beginning, I can directly connect my laptop to this port at the drive. So I can point-to-point connect to the server drive. So let's firstly browse the web page to this server drive, and I can spin the motor. Just do a quickly hardware test. Okay, then let's go to the IE browser. The first time when we log in into this IE browser, this IP address 169.254.11.22. So you can browse this web page, and we can set a password 123478. Okay, confirm 1234578. Okay, and click OK. All right, and after this, we can log in. The username, that's the administrator, and password. Okay, 128. Okay, after we log in, we can see the connection, and we can take a screenshot and write down the hardware number, and also we can see the motor, the highest speed, the rate speed, and the torque value. Okay, and the easy way to test this drive, we can go to the control panel, and we can take control. This can be used to do a quick test, also verify if the power, cable, everything, it can connect it already. So we can set a speed, for example, 60. That could run 1 second, 1 revolution. Okay, and we can hold this hold to rotate. Okay, the motor can run. Meantime, we can also verify if the travel direction, they are correct or not. Some cases, if the motor connected with a mechanical things, with a tool, maybe the tool travel direction is not the same as your forward, then you can go to the commissioning, go to the device, and you can set this motor rotation. You can backward this motor rotation. Okay. Meantime, because now we are point-to-point connect to this drive, I would recommend you write the device name. Give a unique device name. For example, now I'm giving this drive device name drive space red. Okay. So next time when I first time browse a web page, I can immediately know which drive I'm browsing. Okay. And we can also click this backward. All right. So now we can spin this drive and everything looks okay. Here we just briefly spin this motor. Now I will shift to the second drive. And now I can unplug the left side motor and click to the connect to the right side. Okay, now I'm connecting the right side, the blue drive, and I can type in this IP address again. Okay, this drive comes from the factory setting. So the first time I need to set the password, I will set the same thing, 1234567 1234567. Okay, and then I can log in. And the same thing, we can jog this motor. Okay, and we can go to the control panel, power on, confirm, and set. For example, this time we can set a higher, so 120. Okay, then click this forward. Okay, we can spin this blue drive backward. Okay, we can spin this blue drive. In the meantime, we can go to the commissioning device properties and we can rename this device name. And after we rename this device name, you can click this save change. Okay, and the save change. Everything will change from the web page. We need to click the save change. Okay, we can also do a one button tuning from this web page. I will quickly do this. Maybe you can hear some resonant noise. That means the motor somehow need a fine tuning. The fine tuning the speed loop. So you can go to the tuning, commissioning tuning, and you can do the one button tuning. And in this case, as I introduced, I would highly recommend we will do the conservative tuning with this conservative selection. Okay, let's do this, take a control. Okay, it has a fault, then we can clear the fault. We can acknowledge the fault, then go to the tuning again, take the control, select this conservative, okay, and start this tuning, conservative. And it will ask you how long it can travel. The longer travel distance, the better to tune the motor. So in this case, we can write the 5 revolutions. For example, 5 revolutions means 1800 degree. Okay, click OK. Okay, it's complete. This is using the web page. We can do the one button tuning. We can also use the TI Portal Startdrive to do the one button tuning. That's why I only use this web page for the blue motor. Okay, so we can finish this fine tuning. Click the save. After this one button tuning, we can see this is the tuned parameter automatically learned from the system current, and this is the previous value. Okay, and also we can manually tune this value or manually adjust this value. For example, we can go to the parameters, so we can scroll down to see P1460, so speed control P gain. So this is speed controller, and we can manually change this P gain parameter. And after we change this parameter, don't forget click the save change. Okay, so this is the web page, and then we can go to the TI Portal, and I can use the Startdrive to configure these two drives. Okay, let's shift to the TI Portal. And before I shift to the TI Portal, I need to unplug the Ethernet cable and connect to the PerfectNet port. I need to unplug this port and click to the PerfectNet port, the second port. So I can connect the two drive via this PerfectNet port and also connect to the PLC. So I can download the PLC and download the server drive. Okay, this is my TI Portal version 17. I will create one project named S7-1200 and SINAMICS S210 motion control and create this project. Then I will create two drives at first, so add a new device. And I installed the Startdrive software, so I can pick the drives at here, and I can select the SINAMICS S210 and pick the hardware I'm using. Is this server drive? Okay, if you didn't install the Startdrive, it's still fine. That's because you can use the GSD file and create a CPU first, create a PLC CPU first, and then you can drag the GSD, use the two server drive as a GSD file, and set up the PerfectNet communication via the GSD file. Okay, select the drive and select this server drive and click OK. We set up this server drive, and then I will firstly rename this drive unit here. I will right click, rename as drive red. And again, while I'm using the web page, I was connecting this port, but now I'm connecting this PerfectNet port. Okay, so firstly, let me configure this Ethernet address. So for this drive, I will set this 0.10, okay, 192.168.0.10. And I will leave this network, this configuration temporarily here. And then I will double click this motor here. As we can see here, the motor is still wide. We haven't configured the motor yet. So we can double click this motor and go to the motor selection. And then I can pick the motor I'm using. So I can uncheck this filter and select the motor I'm actually using. So I'm using this one, 1FK2102. Okay, without holding brake. Okay, after we select this, we will see all those things automatically pick up because motor and the encoder, they come together from that article number. Okay, and the encoder come from the drive click, so come from the communication. So, and keep in mind the encoder of what I'm using, this is a single turn absolute encoder. So this encoder, some parameter need to be correlated with the TO setting. I will show the TO setting after. Okay, so we configure this. This basically finish everything. And for the communication, PerfectNet communication, we will do after because we haven't set up the PLC yet. So all those PerfectNet IRT, RT communication, so let's temporarily leave there. Then final check, let's go to the web server. And you need to be very carefully if you are going to use this Startdrive to do the configuration. By default, this administrator is disabled, so you need to activate this password. Otherwise, once you download this hardware configuration, you will wipe out the administrator, this username. Then you will find you will never log in via the web page anymore. Okay, and also enable this. Once we enable this, we are able to browse the web page from the PerfectNet port also. Okay. All right, we finished everything and we can save and And then let's create the second drive. The second drive is the same, so I can copy and paste. And that's for the drive blue. Okay, that's for the drive blue. And its motor is the same. So I can double click this device configuration, go to here, and I need to configure the IP address. So go to the IP address, make sure this is the drive blue, okay? And I can change the IP address to 11, okay? And double check the web page setting, click this server drive, go to the web page, okay, the same. So we can copy paste these two stations, and then we can save the project and download the drive to the right. Download. Here, for the port, we need to select this X150. Okay, let's select this 150. Make sure we are selecting the Perfinet port, 150. Okay, and then click the Start Search. Okay, we search this two drive. So this is the beauty why we firstly jump to the web page, because while we jump to the web page, we can set the device name at first. So when you browse the server drives in the network, you can identify which one is which. Okay, so now I'm going to download my drive write. So I name this server drive as a name drive write. So I can select this and click this download. Okay, and enable this save parameterization. Okay, this means copy RAM to ROM. So once we enable this, after we download, then if we cycle power, the parameter will not lost. Okay. We are downloading the left side. And then let's download the drive blue. Okay, download drive blue. Okay, start search. CUX150. Okay, Perfinet port. Okay, pick this drive blue and download. Okay, load. Same thing, save copy RAM to ROM. Okay, we just download these two drives, and we can do this using this commissioning to see if this TI Portal Startdrive software can control both server drive. Okay, we jump to here and click this Go Online. And this is a similar idea as using the web page. And we can see from this commissioning, we can also do the one button tuning and using this control panel. This right drive, we haven't do the one button tuning yet. So we double click this commissioning, go to this one button tuning, we can do the tuning. So let's firstly go to the control panel. We can also using this panel to spin the motor. This is a similar idea like using the web page. Enable and also enable the power. If there's any fault, we can click this acknowledge false. Okay, click reset. We can set. Now the drive enabled. So we can set a speed. For example, this time we can run faster. Okay, 720. And this is the jog move. So I can hold this button to jog it. Now I'm going to jog it. So we can see it can jog. Okay, this is the RPM. Note, this is the RPM. That's why the motor runs fast. So after we confirm this direction and we can spin the motor, that means, so now the TI Portal software can control this drive. This is very good. And then we can reset and deactive. Then we can jump to the one button tuning. Okay, and we can active. And before we start, let's select this conservative. Again, from this application, S7-1200 and SINAMICS S210, we will recommend using the conservative mode. Okay, and then this is the distance, how many degrees. I will spin 18 degrees. So that means 5 revolutions. Okay, and now I can click this start. So meantime, we can watch this previous value and the current value. This is much easier than the web page. We can see those parameters. And again, this is the speed gain. Okay, 1460 the parameter. Click start, and we will see the noise. Okay, we finished those one button tuning, and we will see the parameter got changed. Currently, those parameters only saved into the RAM. To make sure after the cycle power, the tuned parameters still work, so we can click this copy RAM to ROM. Okay, again, we are doing the drive write. And after we save the copy RAM to ROM, and I will also recommend you go offline and upload the parameter to the Startdrive. Otherwise, once you any chance to download this hardware, this drive, then all the offline parameter will override the online drive parameter. So we will do firstly go offline, and then let's click this upload from device. Okay, we will upload parameters from the device because we tuned. Okay, we will click override the offline data. Okay, upload. Good. Now, same thing, we will do the blue drive again because we may override the parameter after in tune from the web page. So I can firstly go to the commissioning. Here, I speed up the video. We will use the Startdrive, this commissioning panel, to test the blue servo drive. Okay, then we can go to the one button tuning. Tune this motor again. Select this conservative. Okay, the longer the better. And then we can click the start. Let's listen this noise. Okay, it complete. We will see those parameters. And also we can manually change this parameter. For example, I can change to 5. Okay, enter. So it online changes this parameter. Okay, and after this, again, don't forget copy RAM to ROM. So we just did this one button tuning. So again, go offline, then upload the parameter. Upload from device. Okay, we upload from the device. Now we configure the two drives. If we go to the device and the network, we will see the two drives are waiting here. Okay, now we can set up the PLC. So if you don't have the Startdrive software, till this step, all I did come from the Startdrive software. If you don't have the Startdrive software, then these two drives, you can pick them from the GSD file. You can install the GSD file, or you can go to the other field device and install the GSD and pick the drive, the GSD file, SINAMICS from here. Okay, for example, the SINAMICS S210 from here. Okay, select the correct firmware. Okay, and now let's set up the PLC. So let's double click this add a new device. And I will select the controller this time. And I will upload the PLC device. Okay, I will pick this unspecified CPU. And I know its firmware is version 4.6, but I can use this 4.5. Okay. All right. After we set up this, click this detect. So I can browse the PLC. Okay, it found this PLC. This PLC IP address 0.2. Okay, detect. Consider as a trust device. Okay. And since this device detected from the online CPU, so its IP address configured already. So let's firstly go through this wizard, security wizard. So we can enable this make this security all opened firstly. Okay. And then let's double click this device IP address, double check this IP address. Okay, 0.2. Okay, and now from the CPU side, we can activate a new subnet network, PNIE_1. And after this, if we shift to the network wheel, we will see the CPU at here. We can move this to drive at the right side. And now we can set up the PerfectNet communication. Again, the 1200 PLC only support PerfectNet RT communication. So let's firstly drag this cable, set up the PerfectNet communication. Keep in mind, drag to this port. So the bottom port, this PerfectNet port is used for the PerfectNet. Then we'll see this means the PerfectNet communication setup. So this device, this is the master device. Okay, device name. Okay, let's drag to here also. Okay, we leave this setting at here, and then let's double click, jump into the drive perfect net port. So since we only communicate via the RT communication, so then this IRT mode we need to disable. We need to disable the, okay, go to the blue also. Disable this IRT, blue, disable. And then let's go to the real-time setting. The system automatically figure out this RT communication, the cycle time is 2 milliseconds. Okay, so you can manually change this value, but I would recommend you can set this value equal or higher or longer than the system assign. Okay, but usually we will leave as the default. Okay, let the system automatically figure out what the time it should be. So 2 milliseconds. This 2 milliseconds is a very important reference value when we set up the TO, the OB91, the cyclic time. So 2 milliseconds for the perfect net RT. And then let's go to the telegram. The telegram here, default telegram, it is using the 105. However, firstly, 105 the system need to do the IRT communication. We have two. We must use S7-1200 PLC. So here we need to pick the telegram 3. Why not 5? That's because for the 1200 PLC, the 1200 PLC only support the standard telegram 1, 2, 3. Usually when we use the VFD communication, we can use the telegram 1. And for the servo control and the closed loop located into the PLC controller, we will use the telegram 3. So let's pick the telegram 3. This is a troublemaker for the new learner when they try to use the 1200 PLC and the SINAMICS S210 or S120 server drive. They select the wrong one, so they can now set up the communication. This is the reason. So we need to select this standard telegram 3, okay, and disable this IRT communication, okay. And then let's shift to the right drive, and go to, and the same thing, select this telegram 3, okay, select this telegram 3. And the right side you will see the system assign this address here. And same thing again, let's check the IRT communication. Click this perfect net port and disable this IRT mode. Okay, and double check. So telegram 3. Okay, after this, so we can temporarily compile. We are now using the perfect net IRT communication. We are only using the RT communication. That's why from this top logic view, we do not need to config the top logic. We only config here. Let the drive knows this is your controller and all the protocol we are using. This is telegram 3. And now we can download these two drives. So because we config the telegram, we need to download the telegram to the drive. So that's why before we config this, I recommend we upload the parameter at first. So because we uploaded already, now if we download, then we will not override the default parameter to the drive. So let's download the right drive. Okay, download the drive right, load. Okay, save parameter, copy RAM to ROM. Okay, and then let's download this drive blue. Download drive blue. Okay, download this drive blue, load. And also leave this, copy RAM to ROM. Alright, after we download both drives, then let's assign the perfect net device name. So go back to this network view, and we can click this network. Okay, and then we can right click, click this assign device name. Okay, because our project includes this device name, the actual device name is this drive blue or drive right. So while we are downloading this project, the device name has been assigned already, but you better also double check the device name. Okay, firstly, let's select this drive right, and let's click this updated list. Then it will browse all the devices from this network. Okay, so if this is the first time, you can pick the drive, and also you can click this flash indicate. Okay, So now we know this is our device. We can click and click this assign name. So it will assign this drive red to this device. And then let's switch to the drive blue and click this update list. And also we can click this device, this IP address and this MAC address also. Let's click this flash, the top indicator. And then we can click this and click this assign name. Alright, after we assign the device name, we do not need to cycle power. Then we can go online. From this TI portal, we can go online. And we can see the status at here to see if the perfect night communicated correctly. Everywhere shows green, that means so now this hardware communication we set up correctly. And next step, we will set up the technology object, set up the TO, positioning TO to control these two drives. Let's expand here and let's click this add new. And we can pick this motion control. And let's pick this TO positioning access. And the first one I can rename this is the access red. Okay, I can manually assign this starting from the 10. Okay, click OK. Positioning access. And we will see the 1200 PLC supply these options much less than the 1500 PLC because the 1200 PLC can do the very basic positioning control only. So the 1200 actually when it's doing the positioning control, it could have multiple ways. So the typical way, this is the PTO using the pulses. So the PTO, this is a high pulses control. This is actually the common positioning way using the S7-1200 PLC. So you can connect to the step motor, the driver. So you can control the step motor. Or you can connect to the low-end servo drive. So the lower-end servo drive, they can receive the high pulses. And the positioning closed loop, it can locate into the servo drive internally. This is somehow like a lower-end servo drive. Also, if you are using the DC motor, so you can connect this using the analog as its output. And you can use the high pulses to read the encoder. So this I used one video. I used two videos show this solution before. You can review. I can paste the link below this video. And then the third one, we will use the perfect drive. The perfect drive means the perfect night RT communication we just set up. So when I pick this, you will see this area automatically updated behind. And then firstly, you can select the unit. For example, in this case, since these two drives, all the disk control directly connect to the drive, the motor. So I can pick this unit as the degree, okay? And there's no simulation because I'm going to select the real drive and the real encoder. Okay, let's go click the drive. And then here, this will browse the hardware drive, the hardware configuration we just did from this network. And the key things behind that is the telegram. We config the telegram as the telegram 3. So when we config the TO, it actually reading this. So let's go back, TO configuration. And here, let's select. So select the drive and select the perfect night and select the right drive. We are configuring the access red. Browse and select this drive red and click this and double check this telegram 3. Okay, select. And note again, the S7-1200 only support the telegram 1, 2, 3. It doesn't support the telegram 102, 105. Okay, so it only support the perfect net RT communication. Okay, now we can see it automatically browse the configuration from the hardware. Okay, we will leave this automatically apply this configuration. Okay. If you spin the motor, if you find the load drives backward, so you can check this, invert the drive direction. And then let's go to the encoder. The encoder, in the real case, the encoder connect to the SINAMICS S210. So the encoder value also transferred from the communication, the perfect night. So we can pick the encoder come from the PerfectNet. So the 1200 also built in the high pulses counter. So the encoder can connect to the high pulses input of the S7-1200. This is the solution if we are controlling the DC motor, and we can use the encoder. The encoder cable can connect to the high pulses HSC, high pulses reader inside. But in this case, the encoder go to the drive. So we will see this diagram updated. It go to the drive, and then we are using the communication to read the encoder. Okay, so we pick this. And then after we pick this, so the system can automatically update. So we pick this encoder from the drive. Okay, right drive control. Okay, encoder. Okay, automatically updated. Okay, again, if the encoder value also shows backward compared with your tool direction, so you can also invert. Okay, and more importantly here, so since we configure this drive via the start drive, then when we offline pick up the encoder, then all those encoder parameters, especially this is the protocol behind. This XRST1, XRST2, they all automatically selected. This is perfect. And in this case, I'm using this rotary absolute, and this is the resolution, and this is steps per revolution. Okay, this is the absolute encoder, and this is the protocol behind. If you are using the GSD file, so you need to manually configure this. Then you better check with the Siemens, check with the drive manual to see the actual type, the encoder you are using to configure this correctly. That's why in this case, I highly recommend using the start drive. Then all those parameters can automatically browse from the hardware configuration we just did. So basically the important things for the drive and encoder we complete. So we can quickly go through those. So basically all those configuration we can configure associated with your application. We can very quick to go through. For example, for the mechanics, for this case, so while the motor spin 1 revolution, so how many degrees represent the load? In this application, the disk directly mounted on the drive on the motor, so it actually spins 360 degrees. Okay, and I can pick so the encoder mounted on the motor shaft. Okay, if you mount it on the load, then you can measure at here. You can select, or the encoder mounted behind the motor, but your load, then your load need to convert to some unit, millimeter or the height. So you can switch the general, change this unit, and then change the mechanics to show per revolution of the servo motor. So how long, what the distance from your load traveling. Module, so the module is doing this cyclical traveling. So I'm now using that. And the position limits, so you can set the software limits or hardware limits. Okay, dynamic, okay, this is the dynamic. You can set the highest dynamic. Basically, those parameters can be used as a default. Okay, general and emergency stop. How fast you like to stop the drive. Okay, and homing, those things you can look at the details. So Siemens provide this diagram. For the active or passive home, this is much easier to understand. And then the positioning monitoring. There's one falling error here. So at the early beginning, especially while you are using the tool has a high inertia. I would recommend disable this selection, or at least you can set a higher value on this window. Otherwise, at the early beginning, either you travel the wrong direction or your closed loop, positioning closed loop haven't tuned perfect yet. Then in some cases you will find a lot of falling errors. Then it will block you testing something else. It is really annoying. So I highly recommend you disable this. Okay. And after you test everything, tune everything, then you can enable. Okay. I'm gonna temporarily enable this. And also stand still. So somehow you need to adjust. So to identify if the motor totally stopped. And then the most important things for the positioning control. So in this case, because we are using the PerfectNet RT and there's no any DIC control, dynamic servo control function. So for the positioning control, the closed loop controller located at the PLC side. This PLC run the role for the positioning control. Then this game is very important. So if you find your position is not accurate enough or the following error too high, then somehow you need to tune this gain, maybe increase. But if you find the gain too high, then you will see the system jerk or vibrate too high. Then your gain need to be decreased. Okay? Then let me quickly do the blue drive also. The blue drive, click this motion control, click this TO positioning axis. And let's do the blue. And let's select this 11. Select the same thing, perfect drive. And select the degree. Okay. And go to the drive. Select the drive. Blue drive. Telegram 3. Okay. And encoder. Select the encoder. Diagram changed. And select the encoder. The encoder also comes from the Telegram 3. Okay, we select it. And the following arrow, you can take off the following arrow and also change the closed loop gain. All right, we finished the TO, and now we can compile and download, and then we can go online and do the commissioning, so we can check if we can use the TO to spin the motor. Okay, and before that, there's one significant things I like to specially introduce is this TO configuration. For this case, while we're using the 1200 PLC, this OB91 plays the role for the communication cyclic time. So if we go to the hardware drive, and while we'll go to the send and receive this telegram 3, we will see the role for this organization block to update this process image. The OB block is this number, MC Servo. MC Servo located here. So this OB91 plays the role to update this process image. Okay, so this is the key role for the communication between the PLC and the drive. The faster the better. However, considering this 1200 PLC is a low-end PLC, and also we need to trade off this PLC need to control something else for your wideband, for your I/O. So this MC Servo cannot set too low. And there's one manual I highly recommend you can read detail at this one page is here. So for the firmware above 5.2, so currently I'm using this firmware 5.2. Okay, so this communication cyclic time we can set 1 milliseconds, but according to this table, so we can see this is the perfect night cyclic time. In my case, I'm using the 2. The system automatically assigned 2 because I'm using 2 drives. If we are using 4 server drives, maybe the perfect night will up to the 4 milliseconds. Okay, and if I'm using the S210, the firmware higher than 5.2, so like my case, look at here, then that means the OB91 can be set 8 or 16 or 12, okay, for this case. So in my case, since my I/O cyclic time is 2 milliseconds, so I can pick this line. That means my OB91 need to set above 12. Okay, need to set 12. You could also set to 8, but I would recommend set higher as possible, because the lower value I hear for this OB91, the higher workload for your controller. So I would recommend set 8 or above 8. So in my case, I will set 12. Okay, then let's go back to here. Let's go to find this OB91 and go to this properties and find out this cycle time. So we can change this value to 12 or even 16. Okay, let's set here. And then don't forget, compile your project, because this OB91 plays a very important role for this closed loop. That's why using the SINAMICS S210 drive, it will be highly recommended using S7-1500 PLC, because S7-1500 PLC is support the Telegram 105. The 105 allows you to deploy the positioning controller into the drive side, that so-called dynamic servo control DSC function from Siemens. So the drive will play the role for the positioning control. Somehow it can release the workload from the controller, from the PLC controller. And also, because the closed loop controller located into the drive, it can react very fast. The bandwidth could be much wider than this role. The PLC runs a closed loop role. This application, this is a low-end application, and in this case, I especially want to use the two drives for this testing. So you can see, so even use this as low-end controller, we can still build up two axis, this positioning control. This could be very simple pick place application, or the conveyor and the pallet, the applications. Okay, so let's download this TO. Let's download the CPU. And also, we better download the drive also. Download the TO, we need to stop the CPU. And since we changed this OB91 configuration, so we better also download the Startdrive. Download these two drives again. So I will download these two drives again. Okay, download. Okay, and then let's download this drive right. Download. Okay, so after the download, we can go online and use the TO to do this commissioning test. Then we can use TO to run, to do a control panel test. Okay, so now let's go to the right drive commissioning. And we can click this active. The active, and we can enable. Enable means power up. So we have error here, we can confirm first. Okay, so before we enable, since this SINAMICS S210, we are going to use this SINAMICS S210 for the positioning control. So let's select this position controlled. Okay, position controlled. This is basically for the power mode. The power mode 0, this is the non-position controlled. And the power mode 1, the default, this is the position controlled. So let's power up. Okay, position control. Then we can firstly go to the homing, so we can 0 this position. So for example, we can set 0 here. Once we click set home, then the position set to 0. And then we can do the positioning move. So there are a couple selections here. So for the position relative or absolute control, we can select this positioning. Then we can set the velocity and the distance. For example, the velocity I can set, okay, 900, not too bad, and we can travel 10 revolutions. And now we can see if I click this absolute, it will travel to 600. And in the meantime, we can also verify if this position can be controlled accurately. Let's go, click absolute. Okay, it stopped at this 3600. Okay, very accurate. This is the positioning. And then we can click this jog for the positioning control, the jogging. So we can, this is the velocity, and this is the forward and backward. I can click the forward. Okay. Stop. And backward. Stop. So I can feel once I release the button, the drive still moving a little bit. After all, this 1200 controller is not high performance. I can see the reaction time is not that super in time compared with 1500 PLC. Okay, but we can see this control position, it can run very accurate. Okay, this is the right motor. Then let's go to the blue motor, disable and deactive. And let's go to the blue TO commissioning. and active. Okay, let's do the positioning control. Enable power up and the positioning jogging. So let's firstly jog it, speed too low, I can set. So I can set 100 here. And then we can see it can run. Okay, so while I'm spinning faster, you can hear the motor is showing a little bit resonant sound. Okay, this comes from, firstly, this comes from the speed tuning, because speed tuning directly controls the torque delivery, right? And also, there's one parameter we can tune. So if we go to the drive, again, this actually associated with the OB91. So let's quickly review this OB91. The OB91, if we go to the properties, so I set this cycle time 12 milliseconds. And consider this 12 milliseconds, this is the cyclic time between the PLC and the drive. And the closed loop, position closed loop is based on this. Then somehow the encoder filter, we need to set a little bit. So for the drive encoder, let's go to the parameter and let's go to the parameter wheel and go online. Then let's go to the P1416. P1416. There's one parameter named the speed setpoint filter, and consider this cyclic time is not that super fast enough. Then this filter we need to set basically the same or even higher than the OB91, that cycle time. For example, they're set as 12. Here we can set a 12, at least the same. Okay, 12 milliseconds. Okay, we set to this blue drive. And then we can also go to the right drive, set the same thing for this parameter wheel and the P1416. Okay, here, the 12 milliseconds. Okay, after we set here, and we can click the copy RAM to ROM to save the parameter to the drive. Okay, go offline and upload the parameter from the drive. Upload. And after we set this, if we go back to this TO, we should hear this resonant sound should run better. So if we go to the commissioning, and we will leave the same parameter, positioning move, power up. Let's set the same value, the velocity 100 and the acceleration 1000, and let's do the forward. Let's hear that resonant sound. And we'll see the motor runs much smoother. There's no any resonant sound anymore. Okay. Okay, so there's no any resonant sound anymore. For the positioning control, firstly we can go to the homing, and we can home that first. So we can set the current position to 0. Okay, we set to 0. Then we go to the positioning. Without setting the 0, set home, so you are now able to move absolute. Okay, you have to go to the homing, set home at first. Then we can set 200 as a distance and set the speed. And let's travel to the 2000 file. And while it's traveling, we can hear the drive runs very smoothly after we set that filter, the P1416 filter. And also let's verify the positioning, this accuracy. Okay, so it stopped at this 2000, very accurate. Okay, so this is using this control panel to verify if we can control this motor. That basically means PLC now it can do the positioning control, because using this TO, this control panel, is a similar idea using the program. As long as you can use this TO to control this server drive, once you program the MC command from your program, then everything should be the same idea as using this control panel. So program the MC command so you can find those motion control, this MC function blocks. I prepared the MC function blocks already, And since this area I used multiple videos to show how to program this already, you will find how to program those function blocks in my motion control playlist. I will now show the programming procedure in this video. Okay, let's use this function block directly. Alright, this IB100, I show how to program this IB100 in multiple videos. And quickly review, inside this IB100, so I have the typical function blocks, for example, power and home. Keep in mind here, because I'm using the absolute encoder, so this mode I set 7. So after your cycle power, your position will not lost. So if you are using the incremental encoder, you can set this mode to 0 or other mode. You can check the online help to see the mode number. And the typical motion command for the jog move and velocity move. Velocity you can trigger and give a velocity command. And for the MC hot, you can stop the motor, right? For the positioning control, you can fire the absolute motion and the relative position. Okay. And then I have the standstill judgment to see the standstill output and the actual velocity drag from the TO. And this TO run as the input and output. So, and this date type, keep in mind for the 1200, this date type named TO underscore positioning axis. So if you have the right mark at here, when you're using this, you better firstly drag your axis to this axis first to let the system refresh, and then you can delete it and program this as the interface. So TO positioning axis. So after you drag this into the program one time, then the system will update internally, okay, to initial this TO, this date type. Okay. Then from the outside, I call this two function block, one for red, one for blue drive. We can see this code is their instant DB. They are DB101 and the DB102. So this is red. I can trigger those commands. Okay, and I can trigger this is the blue. So this instant named blue. And using this IB, I can quickly set up multiple access. Okay, so this is the two function block code. And now I can download this PLC and compile and download. Okay. So this is the basic step by step. We do the start drive at first to test the drive. And then set up the TO, test the TO. The TO basically run the bridge between the PLC and the drive. And then we can program the MC function block to allow the program to control the drives. And then let's go to this DB block drive. This DB block drive is using this date type. So in this date type, I prepare those commands. For example, MC reset, hot, stop, forward, backward, all those typical MC function block, those commands. And I'm using this structure, so when I create this drive red, blue, or other colors, different names, so I can quickly set up all those names. Okay. So basically, every videos I showed before talking about the motion control, I'm using this style. So I will not discuss this at here so detailedly. Okay, so now I'm gonna download. Okay, let's download. Alright, we can use the monitor. Inside this monitor, I'm monitoring this DB. This red and the blue. All those commands and the status come from the OB1, the interface of those IB. Okay, they are all here. So now I'm going to jump into this IB, the instant red, so I can click this online. If I'm going to power up this red at first, okay, I can double click this IB, jump into here, click this monitor. In the meantime, we will see this small button. So this allows us to switch which motor we are monitoring. So for example, now I'm going to monitor the red. So this instant shows this is red, the real status. Okay, now if I'm going to use the red, Okay, monitoring, and if I power on this drive, so I can power on this motor, so we will see this power on will be on. Modify 1. Boom. Now the drive power on, I can hear something. Okay, we power on this right drive, and then I can do the velocity control. So for example, the velocity command is this velocity. So I can fire, for example, 1000. Prepare 1000, and then it's waiting for me to trigger. So if I now trigger this MC velocity. Okay, now the right motor is keep moving. And in the meantime, we can fire up the blue drive. So if I go to the blue drive, so I can temporarily minimize this, switch this to the blue drive, click OK. So now blue drive. So blue drive we haven't powered up yet. So now it's represent the blue drive. We can see, okay, double check. We are running the blue drive. Okay. And now I can open the blue, this monitor list. Okay, blue drive, click monitoring and flow it. All right, now I can power up this blue drive. All right, let's do this test. Now, from this left side and right side, I prepare this watch list. And the left side is the right motor. So the right motor power on, blue motor power on. And now I will firstly home the axis first. Okay, home the axis. So position the all 0. And now I prepare this distance for the right side. And also prepare for the blue side, the speed and the distance. Now I will trigger this move position. Okay, we will see both drive. Okay, we will see both drive travel. And let's verify the position they arrive. Okay, the position arrived very accurately. Okay, if I change to another distance, and this time let me fire to negative. Okay, prepare. Prepare. Okay, and now let me trigger. Okay, their speed is slightly different. And then we can verify the position they arrive. Okay, the position arrived very accurately. That means we can travel both axes at the same time, and if these two drives controlled at the same time, there's no any problem. All right, let's do a quickly summary. Using the 1200 PLC and SINAMICS S210, this servo drive, so we need to set up the telegram, that's the telegram 3. Telegram 3 means the PLC will run as the position closed loop controller. The telegram 3 means while we are doing the positioning control, the PLC will run the closed loop controller. So when we set up the TO, go to the configuration, then the closed loop here, this game, this value, it is the positioning closed loop game. And when we set up the RT communication, we do not need to set up the top logic wheel. Okay, we do not need to set up this. Also, the 1200 PLC does not support IRT. So we only need to set up the perfect night RT. And don't forget, we need to assign the device name. And meantime, we also need to double check the cycle time from the RT communication. So if we double click, and I go to the real-time setting. The system automatically calculates this update time, that's the 2 milliseconds. And then go to the MC Servo. After we set up the TO, this MC Servo OB91, we need to set this cycle time. I set this cycle time, this is the 12. This 12 setting basically follow this table. The cycle time, this is the 2, and I set 12, okay? And according to this, it should be okay. And based on this 12 setting, then from the drive side, and let's go to the parameterization. And I set this 1416, this speed setpoint filter to 12. Usually we can set this time equal or above the OB91, the cyclic time. Okay, the last thing is while we are doing the one button tuning, when we use the Startdrive or web page to do the commissioning and to do the one button tuning, so make sure we are selecting the conservative. After all, for this S7-1200, this small controller, its cycle time and its communication speed is not fast enough. So for the high dynamic positioning control, I will not recommend to do that. So using this test, we can see the 1200 PLC can control this SINAMICS S210. So I'm using this 2-axis. So basically you can use this 2-axis application for pick place or for the pilot or any conveyor control. That's it for today. Thank you for watching. Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe and hit the bell. Thank you for watching.